Thanks for coming, everybody. My name's Steve Mallam, and I'm a sales engineer with InterSystems in Scotland in the UK. Today, I'm going to talk about improving performance of SQL queries and your applications. Now, I'm going to be doing quite a few demonstrations. I'm going to be using InterSystems Iris 2018.1 for those demonstrations. This session is being recorded. For anybody who's listening to the recording, I have put in screenshots from my demonstrations as additional slides I'm not going to show you today. So you'll be able to see those screenshots afterwards. The other thing I'd like to mention is that you've heard potentially a number of presentations this morning that have talked about the fantastic performance available with InterSystems Iris and Cache, and really some amazing numbers that our customers have been able to get out of the system. By contrast, in my session, you're going to see some really slow and rubbish queries. I just want you to know that that's intentional. It took quite a lot of effort to achieve, because if I start off with something that is quick as can easily be achieved out of the box, then I've got nothing to show you. So when my first query takes 15 seconds, that is deliberate, and thank you. This isn't specifically an Iris session, although I'm using Iris. Everything I'm going to talk about is equally applicable to Cache. So, before I get going with technology and demonstration, I'd like to take just 2 minutes to talk about planning for good performance, planning for success. It's easy to say in this room that if I ask the question, when is the time to think about performance, the answer is obviously right at the beginning. But in reality, it doesn't always work like that. I'm lucky I'm in the position now as a sales engineer. I'm usually the cavalry rather than the scapegoat. I don't take the calls from customers who are screaming at me because their system's not working anymore. I guess some of you guys still do. It is much better to not be in that position in the first place. One of my customers from Glasgow once said, volume breaks stuff. He's from Glasgow. Stuff isn't the word he used. But what we need to do in order to ensure good performance and consistent performance of your applications is understand how we're going to test that performance, how we're going to show that the system performs well and will continue to perform well while it's in operation. And, oh, great. I've already had a pop-up. I thought I'd silenced everything. So my advice, test performance early and often, but understand what test data you're going to use to perform that testing. I like to have 3 environments. My development environment, which will have a relatively small set of data. If I've got, say, 4 million records in the real system, I might have 30 or 40,000 in my test set. And then if I can possibly manage it, I like to have a user test system which has effectively a shadow copy or maybe an anonymized copy of the real data, but held to the same security standards, the same sort of hardware, so that you can use that for real performance testing. The number of times that saved me from going into a go live and finding that there was an issue that we'd missed. But it's not just the size of the data that helps with. The quality of the data is something you need to think about as well. And by that, I actually don't mean that you want great data, good quality data, because the chances are your real life system doesn't have really good quality data. If you build a custom test set of data that meets all of your performance testing criteria, all of your functional testing criteria, but you've got, say, an equal spread of all 50 states in the patient, or a person's address field, when you go into real life and discover that 98% of your data is in Massachusetts, for example, then the performance of the queries can be very different. So that's something you want to think about. The final thing I would say on this subject is you need to understand what good looks like. What are you expecting? Does it matter if a query takes 2 seconds? 2 seconds is a long time for a query, but if you're running it once a day, maybe that's okay. If you're running it inside a loop 100,000 times a minute, you've got a problem. So you need to understand for your application what sort of performance you're expecting and when it's good enough. It's also very, very useful to have that information and to maintain it as the system goes into operation. If you have a performance issue with a live system and you phone for support from InterSystems, the first thing that the WRC agent will ask you is, when did this start? If it started today, suddenly, that's a very different proposition to if the performance has been gradually decreasing over time, or maybe it was just always this slow and nobody minded before. If you can't answer that question, or if you can answer that question, it can really help narrow down the investigation very, very quickly. So, I'm now going to talk about understanding what... Did I go off there? I'm going to talk about understanding what's happening inside the system when a query is being performed. The first step to improving the performance is to know what's actually happening. So with that, I'm going to quickly kick off a demonstration query. And let me zoom in a little bit. Find my mouse cursor, which has disappeared. There it is. And then while that's running, I'll tell you what it's doing. I've got a very... That's not the right query here. It wasn't supposed to be that fast. Hopefully this will take about 15 seconds. What I have is a very simple simulated stock exchange transaction system, stock trading system. So I have a stock trade table that has about 10 million rows in it, equally split between buy and sell transactions. Each of those transactions has been performed by one of 20 brokers at about 5, 6 offices in the US. And I've got about 90,000 client records attached to those 10 million rows. And the query I've run here is really the worst possible case. I'm using an aggregate, I hope you can see that, and counting the number of rows that the number of buy transactions for each broker, grouping by the ID. So I hope everybody here is at least familiar enough with SQL and the concept of indexes to be able to follow what the query is doing. But all it's doing is counting the number of rows where a transaction has bought a stock, which means that it has to do an awful lot of work. So how do we know what it's actually doing? Well, I've run the query, but I've got this show plan button. If I click that, then in this case, InterSystems Iris will tell me exactly what was happening when that query was run. I'm not going to go into this in a huge amount of detail because I've only got 35 minutes. But a couple of things I'd like to draw your attention to. What this is telling me is that the plan for the query involves, as each section of the query is running, the partial results are being stored in what's described as a temp file. And what that means is a temporary table is being created in the database in which the partial result set is being stored. So it says file, it's not a text file on disk or anything like that, it is a database table, but it still means we're storing partial results as we go, which is something we'd avoid as much as possible because it's then duplicating work. Now in this, using aggregate, that can't be avoided completely. The other thing I'd like to show, or draw your attention to, is this line here where it says read master map. And what that means is that the query is looping through every single row in that table. It's looping through every one of the 10 million rows in the stock trade table to determine whether it's a buy or sell transaction, which is obviously very slow. So in comparison with that, what I'll do is turn on an index. So does everybody here vaguely know what an index is? All an index is a separate table that allows us to reference directly into the master table based on values in the fields. Now, I actually already have an index for this table. I just turned it off. So I'm just going to turn it back on again now. And then in comparison, I'll show you this on a slide in a minute. If you look at this line here where it says read master map, if I re-show that plan, it's now changed to read bitmap index. That's good. That's what we want to see. We're using an index now instead of scanning through every one of those 10 million rows. So if I run the query again, it'll speed up a little bit. Maybe not as much as we would like. But we've shaved a few seconds off. The reason that it has speeded up so little is because I'm still looking at 5 million rows, I'm still joining to other tables and counting all those values. You know, there's still a lot more work to do. But what I really want to show you here was the difference between the plans. While I'm here, I will also show you this link here. Every query that is run inside Cache or Iris is cached, generated. The query plan that's generated is cached within the database so that if the same query is run again, it doesn't have to redo the optimization step. But if I click on that link, you can just see a little bit more information about the query that's being cached, what it does, and you can even go and see the code if you're that interested. Don't ask me to explain it. So just to reiterate what that's doing, I'll trip over and give everybody another laugh. In the call out there, that's the original version of the query, reading the master map. A full table scan, we're looking at every single row in the table. By comparison, over on the left, we've got the use of the index. One thing, when I demonstrated this, obviously I ran the query and then showed you the plan. You don't actually have to. You don't have to execute the query to see the plan. So you can just keep clicking on show plan as you make changes without running the query again. Now, what I've done is show you a query running interactively inside Management Portal. And that's what we always do in these sessions. How often do you do that in real life when you're developing applications? My guess is not very often. Normally, you're writing code. Sorry, yeah?
That is only cache to this trigger from this interface. If I'm calling it for ODBC.
Okay, so the question is about when queries are cached. It depends on the version you have. In the version I'm using, the queries are cached if they're run interactively or through like ObjectScript code. And I don't want to say a version number because I can't remember which of the forthcoming versions it's in, but all queries will be cached.
Now, if you use this interface to run your queries, you don't use the ODBC connectivity, right?
No, we're not using the ODBC connectivity here.
From here to your database, what kind of connectivity does it use?
Well, in this, we're connecting directly to the database because it's our tool.
You don't use JDBC.
No, we're not using JDBC yet. Potentially. We can take that offline. We can go and talk on the tech exchange about that. If you've got performance issues specifically with JDBC, let's go and talk to the developers. Okay, that's great. Excellent. Where was I? So what I find is you're running an application and you want to know what's actually happening. Well, since 2016.2, we've had a new tab, my cursor's gone again, inside Management Portal, SQL statements, or previously known as SQL statements in this namespace. And what that does is, again, list all of the queries that have been executed on the namespace so we can go back and see exactly what the SQL was. There are some statistics here as well that I'll talk about in a second. So this allows you to run your application user interface or whatever connection you're doing, allow the application to generate the query, and then you can come and find out what SQL statements were actually executed against the database. Potentially improve their performance interactively inside Management Portal, and then once you've understood what you're going to do to improve your query, then you can go back and update your code, which gets you out of that loop of making changes in your code, compiling it, testing it, seeing what happens, which obviously is less efficient. Yeah, another question.
Is that for all users?
For all users with access to the interactive SQL query, yeah. There are also some statistics here. You'll see it's only for a few of the queries. But it's showing me some very simple information like how many times the query has been run and how long it took. The reason that it's only there for a couple of them, ones I made earlier, is because they are generated by an additional utility we have specifically for generating performance statistics. So if I go back to Management Portal and look under SQL Performance Tools, Runtime Statistics, I have a set of options, let me just zoom in again, about what statistics I want to generate. It's turned off by default. The reason it's turned off by default is that it slows down the queries potentially quite a bit. I didn't actually probably give you time to read the numbers there, but a query that took 11 seconds when I ran it interactively without the statistics took 45 with the maximum amount of statistics generation on. And we don't have time to sit and watch that all happening today. So a couple I made earlier, if I look on the View Stats tab, oh, I've zoomed in too much. Let's have a look. Sort on time, pick a query. I can go and see the details of the query, see the query that's being run, and look at the plan here, but instead of just having the information about what's happening inside the query that I had in the previous show plan you saw, I've now got performance statistics as well. So from here, I can quickly see that in this case, the query took 49 seconds, primarily because of the slowdown from the statistics. But the bulk of that time was taken up in Module B. This piece where it's reading through those 10 million rows is what's taking all the time. So when you've got a complex query, this lets you figure out which bit it is you need to speed up. We also, and I'll not show you this again because it's even slower, have the ability to compare performance plans or execution plans. So you can go to the alternate show plans menu option and the SQL performance tools, interactively enter a SQL query, and what it'll do is it'll generate all of the plans that the performance optimizer has considered and let you select them and compare them with the statistics side by side so you can see why the optimizer has made the decisions it has. Now again, if I compare two of those and they take 45 seconds each, we're not going to get much further through the session. So by all means, go and have a play with that later on. So those are a few of the tools we can use to find out what's going on in the system. What do we do about it? Well, the first thing I'm going to mention is the tune tables utility. I'm going to come back to that, but I have some colleagues who would be very upset if it wasn't the very, very, very first thing that I mentioned. I have a colleague who does a similar presentation, and his slide has tune tables 3 times in extremely large letters. But I want to give you some background on what is actually happening behind the scenes so you can understand what it does. The other thing I'm going to mention briefly is parallel processing. How many CPUs can you use? Historically, SQL queries, select queries, tended to be single-threaded. So if you had 8 CPU server, and I've got 4 cores in this laptop nowadays, and you were running 8 queries, that was great, you had a CPU each. But if you're only running 1 query, you had 7 sitting there doing nothing, apart from operating system and the like. In Cache, in InterSystems Iris, we have the ability to tell the performance optimizer that we wanted to use parallel processing. With this little hint, by putting %parallel after the from statement, we can tell, in this case Iris, that we want to perform the query in parallel. And what it does then is it takes the initial set of possible results, partitions them off into multiple sections, gives one partition to each available CPU, and then unions the results back together at the end. And in this case, this query was the best possible case for pretty much for performance for parallel processing. So my performance time went from, 15 seconds to 2.75. It was literally 4 times faster. Now, up until now, we've done that manually ourselves. From 2018.2 onwards, parallel processing will be the default. So you can opt out of parallel processing, but if you upgrade your application to Iris or Cache 2018.2, by default, it'll start processing in parallel if possible. So you have the potential to see some pretty significant performance improvements just out of the box just by upgrading. You also need to be aware of the potential additional load on the CPUs. Your CPUs are going to be used more. But that's great. The system, the little asterisk, is they're just there to remind me that there are some heuristics in the optimizer so that it may make the decision that it doesn't need to use or it doesn't make sense to use parallel processing for a particular query. But in general, parallel processing will be on by default. So let's go back to my demo. Don't know why my cursor keeps disappearing. Pull the same query up. Actually, since I'm here, let's just prove it. If I could type, this many people watching, I could be there all day. And they're 2.4 seconds instead of whatever it took before. But I'll get rid of that because that's cheating. Right. So up until now, I've been looking at all of my brokers in all of my offices. I'm going to change my query slightly. I'm just going to look at the brokers who have their office in, well, on the slides it says Boston, but since we're here, I'll say San Antonio instead. Run the query. So now I'm only looking at about a quarter of the results, so the query will be much faster, won't it? And I would be really embarrassed now if I wasn't expecting this. And it's a little bit faster, it's a couple of seconds faster, but not a huge amount. And if we go back to the query plan, the reason for that is that we are still looping through first the transaction table. We're looking at the 10 million transactions. Now we're using the index, so we're quickly cutting down to the 5 million by transactions, and that's great. But I know something about my data that the optimizer doesn't. I know that I've got 10 million rows in my transactions table, but I've only got 20 brokers and only 5 of them are in San Antonio. The idea of the performance optimizer is to try and cut down the search space as quickly as possible, to eliminate as many possible results as it can, as quickly as it can. So by looping on the transaction type first, I've cut my search space in half. I've gone from 10 million rows to 5 million, give or take. If I looped through the brokers first, then I'd be cutting my search space down from 20 brokers to 5, potentially decreasing the search space by 75%. So what I'm going to do is I am going to tell it, using another hint, that I actually wanted to use the broker table as the first table that it looks at in the query, using this first table hint. And sometimes when I run this, it takes 3 seconds, and sometimes it takes 7 or 8, and I haven't figured out what I'm doing differently in my environment each time. But that is obviously quicker. If I look at the plan, it's telling me that it's now reading the master map for the broker table first. It's doing a full table scan of the broker table. So I'm not thrilled about that. It's doing a full table scan. We'll do something about that in a minute. But I've improved the performance by understanding that I can reduce the search space more quickly depending on which table I consider first. And that's great. And there are a number of other hints I can use to do that. First table, start table, in order, which you can look up in the documentation. But can't the optimizer figure that out itself? Why do you have to know enough about your data to be able to tell Iris, in this case, which order to look at the tables in? That's crazy. And obviously, it can figure it out itself if you let it. There are a number of statistics that the database has for each table. And I'll show you the example in a second, but extend size is an estimate of the number of rows in the table. Block count is effectively the size on disk. And selectivity tells you tells you how many different potential distinct values there are in a given field. So by using the extend size, the number of rows in the table, and the selectivity, understanding how many different distinct values there are, the optimizer has a much better chance of cutting down that search space as quickly as it can. We also have the concept of outliers, which I'll come back to in a few minutes. An outlier is where you have a single property value that dominates your data. Selectivity assumes that each potential distinct value is roughly equally likely to occur. But if you have a system that's running a local doctor's office, the chances are that the vast majority of the patients are based in the same state. So the value in that field is all going to be the same state. Or if you have an issue tracking system that's been running for 15 years, the vast majority of the issues will have status closed. And that can make a big difference to the way the query is run. So we can set those values manually, or we can use the tune tables utility. So if I now go into my management portal again, just asked to look at the tables for my query, and look at the stock trade table. This is the one with 10 million rows in. On actions, I can see the tune table information that's held for this table. Hopefully you can all see that. And that hasn't been set. It could have been set in code, or it can be set using the tune tables utility. I've deliberately cleared it in order to make my queries not work very well. So you can see that it doesn't have any values for these fields at all. And it thinks that we have approximately 100,000 rows, which is quite a lot, but we've actually got 10 million. So I'll just click tune table now, tune this one table. Takes a couple of seconds. It's not looking at every single row in the table. It's taking a statistical scan in order to estimate the values. But it now knows we have roughly 10 million rows, and we have some selectivity values. So for transaction type, we have a selectivity of 50%. What that means is there are two possible values. So 50% chance of any given value occurring. In comparison to that, broker ID, selectivity of 5%. Because we've got 20 of them, so each particular broker ID has a roughly 5% chance of occurring. And the only other one I'll draw your attention to is ID. This has a selectivity of 1, not 1%, 1, because it's a unique field. So having done that tune tables, if I now go back and run my query, taking out that hint, letting the optimizer figure it out itself, actually if I show you the plan first, we can see even without the hint, it now knows that it makes more sense to do a full table scan on the broker table than it does to use the index on the trade table. So if I run that, and now it's taking 2.5 seconds. Because tune tables has generated all those statistics for me and now allows the optimizer to do a much better job of figuring out how to sequence the query. Now, again, I'm cheating. Again, I'm interactively running a SQL query that I designed, and I know exactly where to look and exactly how to improve the performance. So I know by looking at my plan that I wanted it to do a full table scan. Again, back under SQL performance tools, we have the index analyzer option. I'll just update it, which generates a number of reports about the indexes or indices in your system. So I can say, I want to see queries with full table scans, and it'll list the cached queries that it can find where a full table scan was performed in the database. So that allows me to quickly narrow in, rather than knowing already which query I was investigating, as I was doing, I can use this to quickly find those queries that need an extra index potentially. Other reports there, index usage, can be handy. It tells you how many times a particular index that exists already is being used by the queries you have in the system. So in this case, I have one index that isn't being used at the moment. that may be an indication of a problem, or it may be an indication of an index that's unnecessary and therefore consuming additional resources when you update it. And the other reports, which won't show any results at the moment, show you when joins are being done between tables without indexes in place. Got that way. So, I'm deliberately running a query without an index. I'm deliberately doing a full table scan. But let's change that. How do we add an index? This is the really simple bit. You can create an index in Atelier or in Studio in code. You can also, if your code has been set up to allow it, create an index using DDL just in the management portal. The important part is that once you've created an index, you then need to rebuild or to build the data that it uses. Indices are maintained dynamically as the system's running, but if you create a new index on a live system, there are a few steps you have to take. The first thing you need to do is turn off the use of the index. If you've got an index that's got partial data in it, it's being built, and then somebody runs a query that attempts to use that index, the results are undefined. You may, depending on what's in the index, you may or may not get the results you're expecting. So we can use set map selectability to turn off the index. Rebuild those indices either in the management portal or in the terminal. Purge any cached queries that you already have, because you may have queries that have been cached built on the old query plan, which is now subpar. And then finally, turn your indexes back on. So what I'm going to do now is very quickly add an extra index on my broker table, so I don't have to do that full table scan. And I'm going to be lazy because this isn't a live system. I'm just going to type directly and not bother turning it off. So I'm going to go to Atelier. That might be really small for you to see. Hopefully you can see better on the screenshot. I add an index, office index on my office field. Simple as that. Compile it. I personally, as a matter of personal preference, like to rebuild my indices in terminal rather than management portal, because then I get a nice synchronous result that tells me when it's finished. But if I now go back and look at my query again and show the plan, we can see now we're using that index map instead of the full table scan of the broker table, and I can run it. And we're down to about 3 seconds again. If I go back and look at the plan, you can see I'm still reading the master map of the broker table. And the reason for that is that I'm looping through, I'm using the index to find the rows of the broker table that I want to process. But I then still need to go and open those rows to get the actual values out that I'm returning in my select statement, that I'm returning to the user. So I'm returning the broker's name and office. So what I can do about that is I can actually store that data inside the index as well. I can go and say, I want to store the broker's name, which is a member of the base class. That's fine. And the name of the office in the index. Compile it. Rebuild. And now if I just show the plan again, you'll see this read master map will disappear. Because now the data itself that I'm actually interested in using is stored in the index. So I've got a custom defined index just for this query. And it's now down to 2.5 seconds from the 15 I started at. So just to finish off this section, I'll put the parallel back on. And now I'm taking, just over a second instead of 15 I was to begin with. Still pretty slow, but I'm doing aggregate counts of rows, lots of rows, so there's a limit to what you can do. Right. I'm way behind schedule. Let's look at a different type of query. plan. Okay, so to move to a different type of query, one that doesn't use aggregate, I'm going to run a query that is just going to look for transactions where stock of a particular stock has been bought. I'm doing a select star with a couple of different where clauses. Please don't use select star. I'm being incredibly lazy. Specify, some of you are laughing good, specify in your query which fields you want and just use those rather than bringing back everything. That query took about 6 seconds. Again, that's pretty slow. It's looking at 10 million rows. If I look at the plan for that, I can see that it's using my bitmap index for my transaction type, but then using the master map on the stock trade, it's doing a full table scan of the stock trade of the buy transactions to find those with a symbol. So what do I do when I have multiple fields like that I want an index on? Well, really I have two options. I can use what we call a compound index, where we put both fields that I'm going to search on into the index, and I can store the data with it as well. And that is absolutely the fastest way to do it. Only drawback with it is it's inflexible, in that if I then run a query that just uses transaction type or just uses symbol, this index can't be used. Only queries that use both transaction type and symbol can use that index. The alternative is to use a multi-index where we just have two symbol indices on the two different fields and allow them both to be used. It's fast. It's not quite as fast, but it's a lot more flexible. So if I go now and add that extra index, and I'll do it in here this time. And I was taught SQL 25 years ago by a very old crusty Oracle DBA who was very, very, very strict on query format. So it's old habit. Feel free to stick everything lowercase and all on the same line. So I create the index. And because I'm doing it through DDL, actually this will generate the index for me as well. So I don't need to go back and rebuild it. So having built that index, if I now go back and look at my previous query and look at the plan for it, we can now see that it's now using the intersection of those two indices to perform the query, so that when I run it, it's going to be a little bit quicker. So that took, 150, 170 milliseconds instead of the 6 or 7 seconds it took before, just by adding that extra index. So I quite like that. And there it is, a slide. All I did was add the extra symbol index, and I get the improved plan with, somebody else can work out how many times improvement that is. But don't do select star, please, please, please. So something I've glossed over so far, there are different types of index available in Cache and InterSystems Iris, and I've been using two of them without mentioning what I was doing. Those two types of index are what we call a standard index and a bitmap index. Standard index is what you might think of as your normal kind of index, where we just reference, have a lookup, essentially a lookup from the value in the field to the ID of the object. They're very flexible, there's no restrictions on values, and you can store that additional data on them as I did. The other type of index we use a lot is a bitmap index, where the index values are stored as bit strings. So where you have a well-defined set of distinct values, for example, state in an address where there's only 50 possible values, I assume, those indices can be very highly compressed, way faster, really, really, really quick. There is some debate amongst my colleagues about what the upper limit of when it's sensible to use a bitmap index is. I've heard 20,000, I've heard 10,000. That order is fine. If you're up into the millions, or you've got non-discrete values, then a bitmap index isn't a candidate. But if you've got a set of distinct values in the order of 10,000 or less, then a bitmap index is a very good candidate. The other type of index we have, which I'm not going to really talk about too much, is a bit slice index, where the values themselves are stored as bit strings, which can vastly improve the performance of aggregate calculations. but they're expensive to maintain. So it does slow down the update and insert on your data more. I'm told that there are significant performance improvements on that coming, and we'll have some really cool stuff to talk about maybe next year on bit slice and indices, but I don't know the details on that, I'm afraid. The last thing I want to mention in this section is dealing with outliers in your application. So I mentioned right at the start when I was talking about the different statistics in the tune tables information that there's this concept of outliers. So in this screenshot, what I did was I've got my 90,000 clients, my 90,000 customers with randomly generated addresses. But I fixed the generation of the addresses so that a quarter of my customers are in Texas. Don't know why, but a quarter of my customers in Texas. So rather than having a selectivity of 2%, as you would normally expect if you've got 50 distinct values, I've got a selectivity of about 1.5%, which is 49 into 75%. And Texas represents the other 25% of the data. So how's the SQL optimizer going to handle that? When it generates the plan, you've got a query that takes a parameter from a user as to which state they're interested in looking at. How's the query optimizer supposed to know how to treat that? Because if you're asking for customers in Massachusetts, where it's 1.5% of your data, then using that as the first criteria in the join order would be really effective. But if you're looking at Texas, it would be really ineffective. So we have a feature called runtime plan choice. And that is a system-wide SQL configuration option. When you turn it on, the system detects when you compile queries in your code using dynamic SQL or cursors in embedded SQL, if you're looking at a field that contains outliers. And if it does, then it doesn't perform the optimization at that point. It doesn't work out the query plan until the query is run. And then it knows what values you're feeding into the various clauses. So it can then determine at runtime which is the best query plan based on the data you're feeding in. So where you've got outliers in your data, that can really improve the performance and can make the performance more consistent, as opposed to where you select different values and the system suddenly takes longer for particular values over others. So I've got 2.5 minutes left, fantastic. In summary, we've talked about, well, I'm not going to read the list out, we've talked about lots of things. There are a number of other sessions at Global Summit. Some of those we have already missed, but all these sessions are being recorded. So if you're interested in them, obviously you can go and look them up later. I've only talked about functionality that was relevant to both Iris and Cache. One thing I haven't mentioned is sharding, which is a feature-based available in InterSystems Iris only, where data is segregated horizontally across multiple servers, and you then can have parallel processing across separate servers, which is really good for when you have very, very, very large data sets. And my colleague Ian is giving a talk on that later this afternoon. I'm going to go to it, so I can recommend that one. Does anybody have any questions in the last 2 minutes we have? If you could use the microphone, please, so that they turn up on the recording. And be aware that my answer is largely going to be, let's go and talk to the developers in the Tech Exchange.
Hi, my name is Javad. I have 2 questions. One is, I saw an option in the tune table screen where I believe if you check it, the tune table updates itself as the data comes into the table.
Yeah.
So that's true?
Yes.
You tune table once, and then you check that option, and it will keep it updated automatically.
Yeah, it can do. Whether that's wise or not, I mean, our general recommendation is that you rerun tune tables if there is a significant change to the volume or shape of the data you have. You know, tune tables is only a statistical estimate of the data. So if you are performing extra calculations to retune the tables every time an extra value comes in, then you're kind of wasting cycles. You know, if you have 2 health exchanges that merge, and you've got 10 million patients and another 10 million patients, and you put them together, rerun tune tables. If you bring in an extra 1,000 patients, I wouldn't bother.
Makes sense, thank you. The second one is the RTPC option. When you enable it,
Yeah.
the outlier selectivity for individual data is through the tune table. You have to run it, and then the selectivity is calculated for each value.
Yeah, so when you compile, you've got your tune table, the information. When you compile a query in Studio or Atelier, it determines whether you're using any statistics or not. Now, what I didn't really show was those selectivity values, for example, you can set manually in code as well. So you don't necessarily have to have any data. You can set those values by hand up front, and that would allow those to be used as well. Does that answer the question?
Well, so a tune table will always be performed when the system is deployed in production, because your data will never be the same, and tune table is for real-time data.
Yeah.
If I want to enable RTPC, which means that I want a percentage of outliers selectivity as well to be used for faster fetch of the data. When the option is enabled, does tune table happen automatically for all the classes, or all the tables, or do I have to go in?
You would still use tune tables manually, or manually set the selectivity and outlier information.
Thank you.
You're welcome. One more question. I'm over now. I've got a red flashy light down here.
My name's Roger, and it's just a quick question. You mentioned the percent parallel that you use to speed up
Yes.
queries. I'm wondering, like, let's say you have an 8-core processor in your server, but 2 or 3 of those cores are always busy. Is there a way of restricting that percent parallel to say, don't create more than, say, 4 threads, so that you're not actually stepping on other things that those other cores are already doing?
I don't know. I don't think so, but let's go and talk to the Tech Exchange and find out.
All right, thank you.
Sorry. In which case, thank you very much for coming. As Matt said at the start,